In this video, we will discuss determining the greatest common factor involving variables. First, to determine the greatest common factor of variables, we first start with the same process of listing all the possible factors and determining the largest number that is a factor of both numbers. However, you're also then going to remove the variables that are common in all the terms. And we rewrite it as the expression shown at the bottom. So we write it as the greatest common factor of the numbers times the greatest common factor of the variables, which combines to our overall greatest common factor. In our first example, we start by determining the greatest common factor of the numbers. So what we have is, in the first part, this y really has a coefficient of 1. So I'm going to list all my factors of that 1. Now when I do that, the only factors are 1 and 1. The y squared also has a coefficient of 1. So I'd start by listing all the factors of 1, which are just 1 and 1. This allows us to determine that if we're listing our common factors, the only common factor, or the only factor really here, is 1. So the GCF of the numbers is just 1. Now for the variables part, we first have this y, which we know that y is really just a single y. We also have a y squared, and we know that when we have y squared, it's really y times y. What we can see here is that there is this one y that is in common with both. So the GCF of the variables is y. So now when I rewrite this, it's always the greatest common factor of the numbers times the greatest common factor of the variables. So in this case, my greatest common factor of the numbers is 1, and my greatest common factor of the variables is y. So rather than writing this as 1y, I can say that my greatest common factor is just y. And the next example, I again start by listing all of my factors of the number coefficients. So for 27, I can list my factors of 1 and 27 and 19 and 3 and 9. And then for 19, I can list all of my number coefficients of 1 and 19, or number factors of that. Now, when I look for my common factors, the only factor that is in common here is a 1. So the greatest common factor of the numbers is 1. Now for the variables part, my first variable is u, which I know is really just u. And the second variable is also just u. So since both of these terms have just one u, the GCF of the variable is u. So I can rewrite my GCF by using the greatest common factor of the numbers, which is 1, times the greatest common factor of the variables, which is u. So I have 1u, and I know that this really is just rewritten as u. For the next example, I also start by listing my factors. So if I list the factors of 18, I have 1 and 18, 2 and 9, and 3 and 6. Then I list my factors of 27. So I have 1 and 27 and 3 and 9. Now if I look for my common factors, they both have a 1, they both have a 3, and they both have a 9. However, I'm looking for the greatest of these common factors, and the largest of them is 9. So the GCF of the numbers is 9. Now when I look at the variables, I first start with an n squared, which I know is really n times n. and I start with a single n for the second term, which I can rewrite as being just n. Now we see that both of these have one n, so this means that my GCF of the variables is just n. So now when I rewrite my total greatest common factor, I first include the greatest common factor of the numbers, which is 9, times the greatest common factor of the variables, which is n. So I can say that my greatest common factor is 9n. In our next example, I also start by listing my greatest common factors. So if I list my factors of 24, I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Then I list my factors of 16. And when I do that, I have 1 and 16, 2 and 8, and 4 and 4. Now when I determine the common factors here, both of these have a 1, they both have a 2, a 4, and an 8. However, we're looking for the greatest of these common factors, and the greatest of them is 8. So our greatest common factor is 8. Then we're going to consider the variables. So the first variable that I'm looking at is this x to the fourth, which we know x to the fourth is really x times x times x times x. And we have x squared in the second term, which we know means that there's really x times x. So if I'm considering what's in common, these both have two x's. So this means the greatest common factor is those two x's, which I can write as x squared. So now my greatest common factor is the greatest common factor of the numbers, which we got as 8, times the greatest common factor of the variables, which I had as x squared. So my greatest common factor is 8x squared. Now for an example with 3 terms, we follow the same process. So I start by listing my common factors of each. So first I list the factors of 20, which I get 1 and 20, 2 and 10, and 4 and 5. Then I list my factors of 30. So I get 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And then lastly, I list my factors of 50. So I get 1 and 50, 2 and 25, and 5 and 10. Now we want factors that are common in all 3 of these. So we can see that all of them have a 1, they all have a 2, they all have a 5, and they all have a 10. Now the greatest of these factors is the 10. So our greatest common factor is 10. Now I'm going to consider the variable part of these. So I first have x to the third, which we know is really like I have 3 x's. Then I have a single x, which I know is really just x. And I have this x squared, which I know is really x times x. Now, if I look, the only thing that's in common in all of them is this single x. So this means our greatest common factor is x. So now when I put this all together to write my greatest common factor, the greatest common factor of the numbers is 10 times the greatest common factor of the variables is x. So my greatest common factor is 10x. In our last example here, I'm first going to consider my greatest common factor of each of these. So I list the factor pairs of 20. So I have 1 and 20, 2 and 10, and 4 and 5. Then I list the factor pairs of 25. So I have 1 and 25 and 5 and 5. And lastly, I list the factor pairs of 10. So I get 1 and 10 and 2 and 5. Now the common factors that are the same in all of them is they all have a 1 and they all have a 5. So the greatest of these common factors is 5. Then I'm going to list the variables. So I first have y to the third. So I have y to the third is really 3y's. Then I have y to the fifth, which we know is really 5y's. And lastly, I have y squared, which I know is really 2y's. Now, if we're looking for what's in common with all of them, all of these have one y here and another y here. While there's one more y that's in the first two terms, it's not in the last one, so it's not the greatest common factor. So my greatest common factor is the 2y's, which I can write as y squared. So now when I put this together to list my greatest common factor, I have the greatest common factor of the numbers, which is 5, times the greatest common factor of the variables, which is y squared. So my greatest common factor is 5y squared.